Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the IB Chemistry November 2019 examinations. This is a multiple choice SL question from paper 1A worth 1 mark. Let's get started. Here you have some diagram and it's asking us what is the enthalpy of combustion delta HC of ethanol in kilojoule per mole. They've given us some valuable information, so I will just highlight them. We have the maximum temperature, initial temperature, mass of water, loss in mass of ethanol, molar mass of ethanol, and the specific heat capacity of water, along with an equation Q is equal to MC delta T. Okay, they're asking us for the enthalpy of combustion, HC. What is the formula for enthalpy of combustion, or enthalpy in general? Well, the formula, it's in your data booklet. It is actually H is equal to negative Q by N. That's your formula. Okay, where Q is the heat evolved and N is the moles. How do we calculate this though, right? Isn't that what they're asking us? They're asking us to calculate. Take a look at the answer choices. They're asking us to calculate, get us some sort of equation for it. Okay, they've given us this equation as well. Q is equal to MC delta T, right? Q is equal to MC delta T. So can I not substitute that formula in for Q? When I do that, I get H is equal to negative MC delta T over N. I simply just substituted the known equation for Q, and this is also in your data booklet, MC delta T. Okay, so what if I now just substitute all these values were relevant to solve for H? Let's do that. Okay, H is equal to negative the mass, and remember in the formula for MC delta T, you use the mass of the solution that you're looking for heat evolved, because you're looking for heat evolved. In this case, the mass of the solution, in this case, is just water, right? So we're looking at the mass of water, and that's 100 grams, negative 100 times the heat capacity of water, 4.18. But remember, in kilojoule per mole, kilojoule. What is the unit for heat capacity of water? Joule per gram Kelvin, joules. We need to convert this joules into kilojoules. And how do we do this? We need to divide 4.18 by 1000. This will give us the amount in kilojoules. Okay, and this times the change in temperature, which is final minus initial, of the water, which is 30 minus 20. Remember, it doesn't matter what's the unit for temperature. It can be Kelvin or degrees. A change is always going to be the same. Fine. And then over the moles. In this case, not just any amount of moles, the moles of ethanol lost. And how do we calculate moles? N is equal to M by MR. M is the mass and MR is the molar mass. We know the mass of the lost mass. We know the mass of ethanol lost, which is 0.23. And we know the molar mass of ethanol, which is 46.08. Now, this doesn't seem like one of our options, does it? Well, not yet, because we haven't gotten it in the right form. And what do I mean by right form? Well, we can actually change the way I write this equation to match the format of the answers. As 1000 is in the denominator, I can actually bring it down, which would also give me the same answer. So negative 100 times 4.18 times 10 divided by 0.23 over 46.08, and this 1000 just goes down, so instead of divide by 1000 it becomes times by 1000 in the denominator, and that is the enthalpy change and the enthalpy of combustion of ethanol. So which answer is this? Let's see. It's not A, it's not B, it is C. That's your answer. C is your answer. If you have any questions, comment below. Otherwise, like and subscribe, and see you in the next question. Bye.